Chapter 1, Section 3, Unit 1, Section 3. We're going to look at graphing systems of equations, but this is going to be in, undo the move, two variables. Okay, so I will be able to solve systems of equations with two variables by graphing. Okay. A system of equations, two or more equations in the same variables. Okay, two or more equations in the same variables. Okay, good point to know here. How many variables is how many equations you need. So if you've got x and y, if you want to be able to solve for x and y, you need two equations because there's two variables. If you've got x and y and z, three variables, you'll need three equations, and so forth and so on as it goes. We're only going to do two variables for now. All right, the solution to a system, graphically, the point xy where the two lines intersect. If you need to know what that means, it means where they touch. Okay, where the two lines intersect, where they touch. Algebraically, so mathematically, the point xy that makes both equations true. Okay, it is the one coordinate that you can plug into both equations and it actually works. It makes true statements. There are three main types of solutions that we're going to see. Lines that intersect, so you got a line that goes like this, and you got a line that goes like that, and they intersect right there. That is going to be one solution, an x, comma, y. A coordinate that is on both lines. You might have parallel lines. And what do we know about parallel lines? Well, they have the same slope. And if they have the same slope, they're parallel. That means they'll never touch. And since they will never touch, there's no intersection. So this is no solution. Or you might have the O with the slash through it, right? That's a bad slash. Let me see if I can. O with the slash through it. No solution. Okay. And then you might have it to where this line and the second line are the same line. That means that there are infinite solutions. So you might see that as the infinity symbol. You might see it as negative infinity, comma, positive infinity, because the x can go, it goes from anywhere to anywhere. It's not a really great way to say that, but what that is saying is it goes all the way from negative infinity to the left, all the way up to positive infinity on the right. Okay? Important things to know here. Not only is it, let's see, can I make that thinner? Yeah, good. Not only is it the same slope, but it's also the same y-intercept. Okay? So if the line has the same slope and the same intercept, they're the same line, the answer is infinity. All of the points on the line are solutions to both of them. If it's same slope, different y-intercept, no solution. And if it's different slopes, I'm even going to put that on there. Different slopes, then they will definitely intersect. So different slopes, one solution. Same slope, it's either infinity or none. Okay? Things to remember, things to know. Okay. Let's write the system of equations and then identify the solution. So we're going to write an equation for both lines, and then we're going to write the solution based on the graph. So one line, we're going to write them both in y equals mx. There's my mx, and then I've got my maybe plus or minus b. It kind of depends if it's a positive or negative b. So I'm just going to do my fill in the blanks. We're using y equals mx plus b. Fill in the blank, fill in the blank. Okay, so let's call this line 1. For line 1, my slope, I've got 2 points, so it goes up 2 and over 3. So my slope's 2/3 positively. And where it crosses the y-axis is right here, and that is 1, 2 up. Positive 2 up from there. Now my other slope, let's see, here's another dot and here's another dot. 1, 2, 3, up 3 over 1, a slope of 3. And my y-intercept is this guy right here, and it is 1, 2, 3, 4, 5 away from 0, 5 down. So that's going to be at -5 down. Okay, 0, -5. See how it's 0, -5, 0, -5. My b's -5. This one was 1, 2, 0, 2. So that's my thing there. Now, where do they touch? That's this guy here. And I'll do it in a different color even. Let's go, shoot. Yeah, go blue. That's the intersection point. And it is, let's see, 1, 2, 3 over to the right. And 1, 2, 3, 4 up. So my solution is 3, 4. Okay. Y equals something x something. Y equals something x something. Let's see, this will be line 1. And then I guess this was what, line 2. Okay, so that's line 1, so that's line 2. All right. So the solution part is actually pretty easy because that's like if we do our graphing starting on the left, that's one of the points they give us where it touches. Let's see where that is. 1, 2, 3, 4, 5 to the left, so -5, comma, 1, 2 down, -2. So they intersect at -5, -2. Graphically is usually one of the easiest ways to find a solution to a system because there's the dot. Just figure out where the dot is. Now, let's figure out the slopes of these bad boys. Let's see, here's another good dot. So up 1, 2, 1, 2. So up 1 over 1. So that one would be a 1, which we can put in or not put in. It doesn't matter. And the y-intercept is 1, 2, 3, 0, 3. Remember, x is 0, so plus 3. And then, let's see, this guy right here, we are 1, 2, 3, 4 down, 0, -4. So our b is a -4. And my slope, 1, 2, 1, 2, 3, 4, 5. 2/5, double check, my line goes down, my slope should be negative, down 2 over 5. Okay. 3 and 4, you give them a try, pause it, come back, let's see what happens. All right, y equals something x something, y equals something x something. Okay, let's see, this will be number 1, and this will be number 2. All right, number 1, the y-intercept is at 1, right? 0, 1. And its slope seems to be hitting each one of these. A slope of 1, okay? Let's see, 1, 2, 3, 4, 5, 6, 7, 0, 7. And my slope, if it looks down 2 over -2, because down 2 over 1. Where do they touch? Well, let's see. 1, 2, 3, 4, 5, 6. 6, comma. 2, 3, 4, 5. -5. Down 5 is -5. So 6, comma, -5. That's where they hit. All right. Y equals something, x something. Y equals something, x something. Okay, this is going to be line 1. This will be line 2. Okay, line 1. I can do the B real quick. It hits at 0, 2. So plus 2, positive 2. The slope, there's my next hit. 1, 2, 3, 4, 5 down, 1 over. So negative 5. And then my other line hits at 1, 2, 3, 4, 5, 6, 7, 0, 7. So it hits at 7. But my slope, I don't go up or down at all. My slope is 0. So really it's y equals 7. That's the best answer because 0 times x is nothing. So we don't have to write it. Now, where do they intersect? Let's see, we went backwards 1. So that's negative 1, comma, 1, 2, 3, 4, 5, 6, 7. Negative 1, 7. Okay. If one of the lines is horizontal, that will just be that coordinate. If one of the lines is vertical, it will just be that coordinate. It has to hit there because this second line where y equals 7, it's saying y is 7 always. That's what that says. So it had to be a 7 where they'd intersect. Then it's just a matter of how far left and right. Okay. Now, number 5. Sure looks like they're parallel, which means there probably should be no solution, but what we need to check first is that their slopes are the same. So y equals something x something, y equals something x something. Let's count the slopes. 1, 2 up, 1, 2, 3, 4, 5, 6 over. Oh, it looks like there was a halfway point. Look at that. 1 up and 1, 2, 3 over. So because 2 over 6 would be, don't need the calculator right now, 1/3. My intersection point is at 0, 1. So 1 y equals 1/3 x plus 1. My next one, there's a better dot. Look, 1, 1, 2, 3, 1/3. They do have the same slope, and let's see, 1, 2, 3, 4, 5, 6. They do not have the same y-intercept, so there is no solution. Okay. And then number 6, those are the same friggin' line. So that means the answer is going to be forever, infinity. It's a really horrible infinity symbol. Let's see if I can do it better if I focus. There we go. Infinity, like a sideways 8. So all we need is y equals. We need the slope. So 1, 2, 3, 4, 5. 1, 2, 3. 5/3. The lines are going down. So don't forget it's got to be a negative 5/3. Sometimes that happens when you count. Go back and look at the line. What's it doing? Up or down? Okay. 5/3 x, and then 1, 2, 3, 0, negative 4 is that point. So minus 4. And that's what the other line is. Boom, boom, boom. And that's how you solve systems graphically. Okay. So rewrite each equation into slope-intercept form. There's supposed to be a P in there. Rewrite each equation in slope-intercept form. These are your steps that you're going to take. Get them into y equals mx plus b. Okay. Graph each line. Identify the solution. Okay, or the, say we could just go the intersection, right? And really rewrite each equation in slope-intercept form. If you notice the slopes are the same, you might be on a really quick, I don't have to graph this thing unless they say definitely graph it. Okay. But make sure that they're in y equals. Look at their slopes. If they're different, they're going to touch. If the slopes are the same, they might be forever or they might not touch at all. So look to see what their y-intercept is. All right, so solve the system by graphing. So now I have to graph them myself. So instead of them giving me the graph, I have to graph them, see where they touch. So I always start with the y-intercept. So line 1, the y-intercept is 1. 0 left and right, 1 up. And then my slope is 4. 1, 2, 3. Let's see, up 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And then I can also go, because 4 over 1 is the same as negative 4 over negative 1, I can go 1, 2, 3, 4 down, back 1. 1, 2, 3, 4 down, back 1. And then we get this sweet line right here. And I'll switch colors for the next one. Starts at negative 5. 1, 2, 3, 4, 5. And it has a negative slope, so I need to go, right, down 2 over 1, down 2 over 1, down 2 over 1. But I could also go up 2, back 1. There's my intersection, up 2, back 1, up 2, back 1. This is why I like to make a lot of dots. That way I end up making a dot right exactly where they meet. And they meet at, let's see, negative 1, 1, 2, 3. Negative 1, negative 3. That's where they meet. All you got to do is graph them. Okay, next one. Line 1. It'll say, well, this will be red, okay? So 8, 1, 2, 3, 4, 5, 6, 7, 8. And I got a slope of 5 over 2. Now remember that 5 over 2 is the same thing as negative 5 over negative 2. Since I'm already pretty high up on the graph, what I'm going to do is I'm going to go down 1, 2, 3, 4, 5 over 2. Yep. And then 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. 1, 2, 3, and I'm off the graph. So now I can just connect my dots. And then I can switch to my next line. Starts at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And it's negative 1, 6. So I can go up 1, back 6. 1, 2, 3, 4, 5, 6. Oop, that's where they meet. Da-na-na-na. Got it. Now, what's that solution? Well, it's way the freaking heck over there, isn't it? How many? I'm going to go down. Let's see. 1, 2, 3, 4. I lost it. 1, 2, 3, 4, 5, 6. And it's negative because I went to the left. And then 1, 2, 3, 4, 5, 6, 7. Negative 7 because I went down. There's my solution. Okay. Oh, let's see. Where do they cross? First one, 5. 1, 2, 3, 4, 5 is my y-intercept. And my slope is 1, up 1 over 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 1, down back, 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 down back. Might as well dot them all. That way when I run into it, I know where it is. Don't forget the arrows on your lines because the lines do go forever. Negative 7. Well, let's see. Start at 0. 1, 2, 3, 4, 5, 6, 7. Okay. That dot. And then negative 3. So I can go down 3. 1, 2, 3 over 1. But that doesn't take me towards my line. So don't forget that that is the same as 3 over negative 1. So we could go 3 up. 1, 2, 3, back 1. 1, 2, 3, back 1. 1, 2, 3, back 1. Found it. We know where they intersect. 1, 2, 3, negative 3, and positive 2. They do have different slopes. They're even different signs, so we know they're going to definitely intersect. One starts up at 8. One starts down at negative 8. Didn't we just do this one? It's very similar. Okay, so red line first. Positive 8. 1, 2, 3, 4, 5, 6, 7, 8. 3/4. I can't even go up 3, so I'm going to go down 3. 1, 2, 3, and over 4. 1, 2, 3, 4. Right? Because negative 3 over negative 4 is the same thing. 1, 2, 3. 1, 2, 3, 4. It's going to be one of those 3 dots. Now we just have to figure out which one it is. It's going to be a long count. 1, 2, 3, 4, 5, 6, 7, 8. Negative 5 over 4. I'm going to go 5 over negative 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Found it. And 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 to the left and 2 up. Negative 8, 2. Okay. Let's see what happens here. Next piece. Well, the first line starts at 2. And it goes up 1, 1, 2, 3, up 1, 1, 2, 3, up 1, 1, 2, 3, down 1, 1, 2, 3, down 1, 1, 2, 3, down 1, 1, 2, 3. Graph. Don't forget your arrows. Now, the last one, this says x equals 9. That means x is 9 always. So that means that my solution, the x part's going to be 9. I go over here, 1, 2, 3, 4, 5, 6, 7, 8, 9 in the x direction. And then x always has to be 9. That's a line that goes like this. It has an undefined slope, but it still has an intersection point right there. 9, comma, 1, 2, 3, 4, 5 up is where it works. Okay? That's where those intersect. Let's look at the next one. Oh, I did them both the same color. You get it. All right, these have the same slope. Look at that. And they have different y-intercepts. I already know that. There is no solution. But let's graph it just to make sure. So negative 5. 1, 2, 3, 4, 5. Up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. So it's this line right here. And then we also start at, there's nothing back there, so that's like plus 0. So I start at the origin. I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2, back 1, down 2, back 1, down 2, back 1, down 2, back 1. And the more dots it is, the easier it is to connect the dots and make the lines. They're parallel, no solution. But I saw it early right here. Same slope, different y-intercepts. All right, you try these two, give it a pause, take it a try, graph the lines, make sure that they're y equals first. Notice that this one's not and this one's not, so make sure it says y equals first, then graph. Okay. While I'm looking at these two lines, I already know that this one says y is negative 3. So the y is going to be negative 3. We just need the x part. I'm going to graph that line first. 1, 2, 3 down. That's where y is negative 3. And it will always be negative 3 horizontally on this line. So the one I need to work on is the 2x minus 3y equals negative 3. That negative 3 is not the y-intercept yet. I need to simplify that. So let's see, I'm going to do some work right here in the middle. 2x minus 3y equals negative 3. I'm going to move my 2x because I want the y by itself. So negative 3y equals negative 2x minus 3. We always start on the outside, work our way into what we're solving for. Then get rid of the negative 3. Everybody divides by negative 3. The negative 3y, the negative 2x, and the negative 3 at the back. So that makes negative 3 divided by negative 3 is 1. So that's y equals. Negative 2 divided by negative 3 is positive 2/3 x. And negative 3 divided by a negative 3 makes a positive 1. So we start at 1. And we're going to go up 2/3. Up 2, 1, 2, 3. That's not the direction I need. So I'm going to go down 2, back 3. Down 2, back 3. And I find that point of intersection. 1, 2, 3, 4, 5, 6. Negative 6, negative 3. Okay. 1, 2, 3, 4, 5, 6. And up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1 back, 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 down 1 back. Boop, 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 boop. And now I got to do some work. Minus 2x. Negative 2y equals negative 2x minus 12 Divide by -2, everybody. Y equals negative and negative makes positive 1x. Negative, negative makes plus. That makes a 6. So it's the same equation. So, and the solution is forever. Okay? So if you get the same slope, so this one was a 1 and that one was a 1, that's the same slope. And the same y-intercept. Same line, forever. Same slope, different intercepts. No solution. Different slopes, definitely one solution. Got to find it. Okay? So, there you